Okay, so I believe that we are live now. So, welcome to Virtual Mentors Club. I hope y'all are having a great winter break. And please let me know in chat if you all can hear me or if there's any audio issues or anything like that. And we will get started in just a couple minutes. So just wait for a few more people to get on in case they're running a bit late or anything like that. Okay, so I think it's almost 4:03, so I think we'll get started with the stream for today. And today I will be going over the TEKS 3.3D to 3.3F, and these TEKS cover fractions, more advanced concepts with fractions. So if you don't know much about fractions, yeah, I would recommend that you watch the last live stream first, where I did TX 3.3 A to C, and in that live streams where I went over more basic problems related to fractions, and today's will be a little more advanced. So with today's stream, there shouldn't be much calculations and all, so I think today's stream shouldn't be too long, so all of you guys can enjoy your break. And let's just get started so I don't have to waste any more of your time. And the first problem I'll be doing, all three of today's problems are from the 2018 third grade math star, and the first one is problem 23. And this is a TEK 3.3D. So the problem says there are 4 books on a shelf. In the model, the shaded books represent nonfiction books. And here we pretty much have a model showing 4 books on a shelf. And it's asking us which expression represents the fraction of the books on the shelf that are nonfiction. So, of course, as usual, let's first make sure to highlight anything important from the problem. And important parts to remember are that there are, just that back, sorry about that. There are 4 books. I don't know why it's doing that. There are 4 books. 4 books on the shelf, and shaded books represent nonfiction books. And it's asking us which expression represents the fraction of the books that are nonfiction. So it's asking us what fraction is nonfiction. So let's think about how we need to do this. So what we can do here is we can see what fraction of the total each shaded book is, and if we add up all of the fractions, we will get the total fraction of the books that are nonfiction, since shaded books are nonfiction. So the easiest way to do that is, first on each book, let's just label how much of the total is, each shaded book, since we only need to know the nonfiction books here, the fraction that are nonfiction. So, if you guys remember, let me just write it over to the side here. A fraction is a part over a whole. Part over whole. That's what a fraction is. And so for each book, it's just one part. And we know what the whole is also, because in the problem we were given here that there are 4 books on the shelf. And with that, that means that we know that for all of these, the denominator is just going to be 4, since that's the total, the whole. And each of these is just one part. So that's one part, that's one part, and that's one part. So I don't know why these are getting cut off. But each of these is one part. So in order to get the total fraction, we can just add 1/4 plus 1/4 plus 1/4. That would be the total fraction of the books that are non-fiction. We're adding each of the individual fractions to get the total fraction. And we don't need to count this. Move that back. We don't need to count this book right here, since it is not shaded. We only are talking about which ones are non-fiction or which ones are shaded. And now that we have 1/4 plus 1/4 plus 1/4, let's just go through the answer choices. A says 1/4 plus 1/4 plus 1/4 plus 1/4. Now that is too many fourths. So we can say it's not A. We're not saying how many total books are there. Then we could maybe say that. But this problem is only asking for the number of non-fiction books. So, sorry that keeps readjusting, but this one is incorrect. B says 1/4 plus 1/4 plus 1/4. This one is correct. That's what we got. So we can circle that choice for now. C says 1/3 plus 1/3 plus 1/3. This is incorrect because that indicates that there are 3 total parts, but there are 3 parts are shaded, sorry. But there are only 3 total books. It's saying that the whole is 3. So we know that there are 4 books, and so that has to be incorrect. And answer choice D says 3/1 plus 3/1 plus 3/1. Now this one is completely off, because what this is saying is that there are 3 parts over 1 total part in the whole, and that's just not possible. We can't have more parts than a whole. So this one here is incorrect as well. And it stops readjusting. We can finally say that B right here is our correct answer choice, which is 1/4 plus 1/4 plus 1/4. So does anybody have any questions about this problem? So I will just wait about 1 minute to see if anyone has any questions on this. Please let me know in chat. You can just type it in chat if you have any questions. So it doesn't look like we have any questions, so I'm just going to move on for now to the next problem. And that would be this one right here. So this one here is problem 15 from that same test. Problem 15 from the 2018 Math Star. So problem 15, and this one is the T 3.3e. So let's read the problem. It says, the picture represents the trophies 3 brothers have on a shelf. Each brother won the same number of trophies. So in this case, there are a variety of ways that you could think about this problem, but I will be showing one way that you can do this. And the way I would do this is that it says that each brother won the same number of trophies. So what we can do is we'll use red for one brother, blue for one brother, and green for one brother. And let's just start distributing these trophies equally between each person. So let's use red here first. And let's say, okay, brother 1 gets this first trophy here. Let's circle that. Brother 2 gets this next trophy. Brother 3 gets this next trophy. And again, we're going to start giving brother 1 the next trophy. This is brother 1's second trophy. This is brother 2's second trophy. And this is brother 3's second trophy. So now what we've done is we have given each brother 2 trophies. Brother 1 has 2 trophies, so there's 2 red circles. Brother 2 has two trophies, so there's 2 blue circles. And brother 3 has 2 trophies, so there's 2 green circles. And now we can find the fraction. Since all of them have the same part and it's the same whole, the fraction for all of them is the same. So let's just calculate the fraction for the red for now. So if we write it as a fraction, we have a fraction is, let me just write it again here. It is a part over a whole. So in this case, we have our whole is 6. There's 6 total trophies between the brothers. So if we count them up, 1, 2, 3, 4, 5, 6. 6 total trophies. And next, we can see a part. So let's just take brother 1 for example. So brother 1 got 2 trophies. So that's his part. He got 2 trophies. Now, let's say we don't have to since we know they're all equal. But let's say we did do the same for the 2 other brothers. For brother 2, he also got 2 trophies. So 2 parts over 6. Brother 3, he also got 2 trophies. 1 and 2. So that would also be 2 over 6. So what we're getting here is that no matter what, we are getting 2 over 6. And if we go through the answer choices, not 2/3, 2/6 is what we got. We can put a question mark. It's not 3/6, and it's not 3/3. So our answer here is just 2/6, since that's a fraction we got from doing this. We got that each brother out of the 6 total trophies has to get 2 trophies out of the 6. So that's how you do this problem, and that's one way to do this problem at least. There are many ways you can do all of these problems, but I'll just be showing one for now. So please let me know in chat if you guys have any questions about how to do this problem. And I'll wait just about a minute to see if anybody has any questions. So if nobody has any questions about that, I will now do our last problem for today's stream from the TEKS 3.3F. And this here is problem number 8 from the same 2018 Math Star. So I'm going to make it a bit smaller so we have some space to work on the side. I think that's about good. So let's read this problem. 4 fraction models are shown. Which models are shaded to show equivalent fractions? Now, here I will be showing a way that you can get equivalent fractions taking any 2 fractions, and how to simplify fractions pretty much. So for model 1, you can tell that there are 2 parts out of 3 total parts. So the whole would be 3. The whole here. I don't know why it keeps doing that. Sorry about that. Model 2, we have 4 shaded parts out of 6. And model 3, we have 1 total part out of 3. And model 4, we have 4 shaded parts out of 4. So those are our fractions. Let me, the 6 is kind of messy. Let me rewrite that. There we go. So these are our fractions. So just looking at it, we can say that model 4 is just completely full. So model 4 is not equivalent to anything else. So just like that, we can cross out interchoice 8, because model 4 can't be equal to anything else if it's just the whole thing shaded in. Now, what we need to look at here is, are there any figures where we can pretty much get rid of any of the lines pretty much, and it won't really change much? And in model 2, we can do that. If you see this middle line here, it's not really doing much. So what we can do is we can actually redraw that same box here. Let's just redraw it down here for now. Sorry about that. Let's redraw another box like that. And we split it up into pieces like that. We can recolor it like that. We can shade that in. We shade that in. We don't shade in the middle. And right here, we pretty much have 2 equal fractions. And now we can write this as a fraction, and we can say that this is 2 parts shaded out of 3 total parts, 2/3. Now another way to think about this is that if you take this 4/6 right here, what we can do actually is, you can see in both in the numerator and denominator, you can divide it by the number 2. So if we divide that by 2, divide it by 2, that is 2 over 3. So this allows us to see that the fractions 4/6 and 2/3 are equivalent fractions. Now the word equivalent really just means equal. So what it means is both of these fractions pretty much represent the same thing. So now that we know that model 2 is 2/3, is the same as 2/3, we can say that, well, model 1 is also 2/3. So model 1 and model 3 are equivalent. So we can just write that at the bottom here, model 1 and model 3, I'm just going to write M for now, are equivalent. And we can even write here that 2/3 is equal to 4/6. So now if we just go back to our answer choices to actually answer the question, we are saying that, sorry, this should not be model 1 and model 3. This here is model 2. Model 1 and model 2 are equivalent. So with that, if we go to our answer choices, F says models 1 and 2, and we just said that that's correct because 2/3 equals 4/6. So I'm just going to circle that for now. Z says models 1 and 3, which are not equal, because if we take a look at the models themselves, this is 2 parts out of 3, and this is 1 part out of 3. And if you have a different number of parts out of the same whole, that means that there's no way that the two can be equivalent. So Z, we can mark it incorrect. And answer choice A says models 2 and 3. Now this one is 4/6, or as we calculated here, the same as 2/3 if you look at this. And this is 1/3. And just like we did for models 1 and 3, we know that if we have this different number of parts out of the same whole, the fractions cannot be equivalent. They're a different amount. It's like saying we have 2 different equally sized pizzas, and we're cutting each pizza into 3 slices, and we're taking 2 slices from one pizza and 1 slice from the other pizza. They can't be the same amount because the pizzas are the same size, so the pieces are the same size, and if you have more pieces from one pizza, it's going to be a larger amount. So we can say models 2 and 3, that's not the answer either. And just like that, we're left with only models 1 and 2 as correct. So does this one make sense? Please let me know in chat if you guys have any questions about how to do this problem. Okay, so if there aren't any questions, then that's it for today's live stream. So I hope you guys all have a great winter break, and see you guys later.